A couple more questions here. Here's another problem, both in standard form, and I could do anything I wanted here. I could graph, I could substitute. I'd need to do a little work to get there, but I also could use elimination. The problem is if I look, there's no multiple, there's nothing I can do to one of those equations to get to the other, to get to the other coefficients. So what can I do? Well, I can easily multiply both of those equations by something. That's fine. I could also, if I look at that first equation, all of these coefficients, all those numbers are divisible by 2. If you want to divide by 2, great. Go right ahead and do that. Make your numbers smaller. You can do anything you want here. What I'm going to do, let's see, I have to decide, make the call, and it doesn't matter one way or the other. Do I want to eliminate the x or do I want to eliminate the y? I'll eliminate the y because the coefficients of the y's are a little bit smaller. So what I'm going to ask myself is, what's a common multiple of both 8 and 6? I could use any common multiple. I could even pick 48 because if I multiply 8 and 6, I can get to that value. But the smallest common multiple of those two numbers is 24. So what I'm going to do is I'm going to multiply the top equation through. To get to 24, I'll multiply by 3. And the bottom equation, now I could multiply by 4, but what I want to do here is eliminate, right? So I'm going to make the signs work for me as well. I'm going to multiply that bottom one by -4. And that's a lot easier for me to do. It's easier for me to add things together than subtract them. I lose track of my signs. So if I rewrite these, that's 30x plus 24y equals 6. And then with the other equation, now I'm going to have minus 32x plus 24y. Again, remembering to multiply the other side as well, equals -4. So the thing to keep in mind here, those equations are exactly the same thing, right? That's the same equation, just rewritten. All we did was multiply. We kept it balanced, rewrote them by multiplying both sides of the equation by the same value. We kept it balanced. They're the same thing, but now they work for us. They didn't work for us over here. We had to do too much thinking. But now this is a piece of cake. Sorry, and this should be a minus sign, right? I add those together. I get -2x equals 2, x equals -1. That was easy. A little bit of thinking and manipulating those equations to make them work for me, and that was a piece of cake. And again, going back to solve for y, we want to substitute into whichever equation looks best for us. I could use the two new ones. I could use one of the first ones. I'm going to use, I think, this bottom one just because the numbers are smaller. So 8 times -1 plus 6y equals 1. That's -8 plus 6y equals 1. I'm going to add that 8, so I get 6y equals 9. And dividing by the 6 is going to give me a fraction here. That's okay, not a crazy fraction. Y equals, if I reduce that, 3/2. And of course, I would accept 1.5 or 1.5. Any of those are fine. Okay, so again, make these equations work for you. You got this. Piece of cake. One more quick example. I'm not going to do this all the way out to the end. I just want to show you what I meant by subtracting is harder for me. If I look at these two equations, I notice that I have 18y and 18y. I can't add those two equations together because the y's wouldn't eliminate. I could subtract them. The problem is I make mistakes with my signs. If I subtract, I have to remember to subtract every single piece. So 2x minus 4x would be -2x. 18y minus 18y would be 0. And then I have the 9 minus -27. There's a pretty good chance I'm going to get that wrong. So instead of, I always teach this, let's do this the easiest way possible. Instead of subtracting, what if instead we multiplied that bottom equation by -1? That's easier. Now I've got minus 4x, or we could multiply the top one, doesn't matter. Minus 18y equals positive 27. And now I can add, and I have less of a chance of messing up my signs that way. Okay, so that's always a possibility. Do whatever you want, whatever makes you happy with these.